Hi, and welcome to Teens Teach Math. Today we are going to be proving the isosceles triangle theorem. To prove the isosceles triangle theorem, you first have to understand what it's asking. The isosceles triangle theorem says, if two sides or legs of a triangle are congruent, then the angles opposite those sides, or the base angles, are also congruent. Now let's get into the proof. First write down what we know and what we are trying to prove. Well, we know that the triangle ABC is isosceles, and we are trying to prove that the base angles are congruent. So we are trying to prove that angle ABC is congruent to angle ACB. In this proof, we will be using the SSS postulate to prove the isosceles triangle theorem, which means to prove the isosceles triangle theorem, we need to prove the three pairs of sides are congruent. In the first step of our proof, we're simply going to be writing down our given, which is triangle ABC is isosceles. The reason for this would be the definition of an isosceles triangle. Now, because triangle ABC is isosceles, we already have two congruent sides, which are sides AC and AB. This is true because it's a definition of an isosceles triangle. Next, we would place a point down in the center of line BC. This point would be the midpoint of line BC, and would cut line BC into two congruent lines. Now down in your proof, you'd write construct a midpoint, because that's what we did. And the reason we could do this would be because of the midpoint postulate.
Now, because of the midpoint we placed down on your proof, let's call it point M, you'd write line BM is congruent to line MC, and this is true because of the midpoint postulate. After we have made the midpoint, we connect it to point A, making a new line segment AM. We are able to do this because of the line postulate. Now, in your proof, you'd write that line AM is congruent to line MA. In other words, the line is congruent to itself because it's the same segment. We are able to do this because of the reflexive property of congruence. Now you see that we have three sides that are congruent to each other. Once you have all three sides, bring them together so that you have triangle AMC is congruent to triangle AMB. This is what we've been getting at the whole time, and it's because of the SSS postulate. But don't forget, we're not trying to prove that the triangles are congruent. We're trying to prove that the base angles of the original triangle are congruent. How, you may ask? Well, we've already proved that the two triangles created by the line segment AM are congruent, which means that the triangle's corresponding sides and angles will be congruent. We know this because of CPCTC. Congruent parts of congruent triangles are congruent. So as your final step, you write in your proof that angle ABM is congruent to angle ACM by CPCTC. And with that, you've proved that the base angles are congruent. And that also proves the Isosceles triangle theorem. Thanks for watching, and don't forget to hit the like and subscribe button below.